is recording. Okay, so okay, good. So for us now to compute correlation, okay, for us to compute correlation, we already need, or we first need to compute what? We first need to compute covariance. Okay, in our yesterday's class, we computed covariance already. So now we already have the what? The covariance. So, and remember that we said that correlation is given by covariance, okay, of x, y, and y, of x and y, divide by what? Standard, that is ST-dev, okay, standard deviation of x, okay, multiply by standard deviation of what? Of y. That's what we said. Okay, that's what we said. I can just treat this as a text. Let me treat that as a text. So text. So basically you can see this is the formula, okay, which we talked about yesterday. I remember I illustrated it, okay, while doing illustration for covariance. So this is the formula we'll need now, or for correlation. For us to get correlation, we'll compute the covariance, okay, then divide by what? The product of standard deviation for the two variables, okay. Yes, so that's what we are going to do. And also when it comes to inbuilt Excel function, correlation does not take a they does not either take a population or a sample. Okay, so the function which we have, it is for calculating covariance for both sample and what? And the population. Okay, so correlation is correlation, whether we are working with sample data or we are working with what? Population data. Okay, so our first point now is to compute what? It's to compute the standard deviation for x and standard deviation for y, because we already have what? Because we already have what? The covariance. Okay, I don't know, someone has a question, or okay, is it only me, sir, who is or it's lagging? So can you hear me clearly? Am I clear, or am I breaking? If I'm clear, maybe by a show of thumbs up. Okay. Um, maybe Brian, you might check on your internet. Okay, please check on your internet, because the rest can hear me clearly. Okay, all right, thank you for that. Okay, good. All right, yeah, sure. So good. So we need now the standard deviation. Okay, of course this will be sample standard deviation for y, and standard deviation, okay, standard deviation for what? For x. All right, so in this case we are going to say standard dev, or ST-dev, of sample data for the what? For our x values, that is for the household income, okay, and also for the what? Standard deviation for our expenses. Okay, so standard dev also dot s for what? For our expense. Okay, so these are our two standard deviations. Okay, now meaning we can now calculate what? Correlation. Okay, so our correlation will be equal to our covariance, okay, divide by product of standard deviation for x multiplied by standard deviation for y. Okay, and then you can what? You can now run. So you can see our correlation is what? Is 0.649. 0.649. Okay, this is our correlation. Okay, before we can before we can now interpret this value. Okay, before we interpret this value, we can now do the inbuilt excel function, so that now we may interpret what this value means. Okay, what this value means. So in this case, we are going to say it is equal to correlation correl. Okay, correl, you can see it returns correlation coefficient between two that is variables. Okay, so correlation. So in this case, we are going to that is to highlight the first array and also the second array. First array being our first variable, which is the household, our household income. Okay, and the second variable is our household expense. Okay, so we are going to highlight that. Then that we close the first range with a comma, we go now to the second what? To the second range. Okay, once we are done, you close the that is the function, and then you run, and you can see for sure we are getting what? We are getting two variables. Okay, the same value, sorry, we are getting the same value, meaning our two that is the both approaches. Okay, or our mathematical approach is also correct. Okay, we did not miss anything when we were computing what? Correlation use mathematical method. Okay, all right, good. What does this value mean? What does this value mean? Someone, what does the correlation, that is the correlation value of 0.649 mean? Someone, aim.
Uh, we can say that 64 of the times the two variables are correlated to each other.
That is 64%.
Yeah.
Okay, of the variables are correlated. Okay, I would also need another, maybe another suggestion. Maybe now in reference to the income and expense. Someone, Jamvia, is it Jamvia? I can't remember the other pronunciation. Any idea, Xavier? Okay, Maureen.
Okay, before I give my opinion,
Mm-hmm,
I'd like to ask a question. Okay, I've followed the instruction on how to calculate the inbuilt,
mm-hmm.
but my answer is 0.64. It's different from the mathematical one. I think I've
What?
gone wrong somewhere.
And a mathematical one, maybe you might have gone wrong. And
And the mathematical, what is the answer under mathematical?
it's still
Oh,
0.6. Still
okay.
this
So I
one.
think I'll redo it. Okay, I'll redo it later.
Yeah.
I'll redo it later. Okay. Now, then, if it is 0.6, in my opinion,
Mm-hmm,
it might mean a relatively strong positive relationship between the two variables. Yeah, they are strongly related. They have a positive relationship.
Okay. Yes, of
Yeah.
course there is a that is a relationship. Okay. We have a moderate, strong, positive relationship. But in terms of now income and expenses, how can we infer or how can we conclude using this value?
Can we use the same whatever we said in it was covariance, that they are strongly related. That is when one in okay, it's the same thing. When one increases, the other increases.
Yes, if they are positive, it means they are moving the same
The
direction.
same direction. Yeah.
Yes. But I am trying to find something.
Okay.
Yes. Okay. Maybe just to explain and also save time here. So basically, our that is our output of 0.49. Basically, it tries to mean that, like, or first, the value is showing us that we have a moderately positive linear relationship. Okay, we have a positive linear relationship between what? Between these two variables. Okay, remember during our that is our during our um, uh, explanation or define while we were defining correlation, we say that it is a statistical measure. Okay, and in this case it quantifies. Remember, for that is for covariance, it does not quantify the strength. Okay, but it shows us more of the direction or the movement of what? Of the two variables. Okay, but now for correlation, tries to quantify the strength and also maybe the direction of the linear relationship between maybe the two variables. Okay, remember we also say that that is covariance. Okay, that is correlation, sorry. That is ranges between -1 and what? And +1, meaning we cannot get we cannot get a value which is greater than what? Which is greater than 1 or less than negative what? -1. Okay, just like a summary of what we discussed, that is in our last class. Okay, but now, when if we were to infer this, okay, if we were to infer maybe this value in reference to our in reference to our data, we would say that first of all, the value shows that we have a positive linear relationship between income and what? Expense. Basically, this will mean that the individuals, okay, or the individual income, or the individual that is the individuals uh, who earn, let me just go to one side. Like, if you earn more that is income, okay, so you tend to spend what? You tend to spend more. Okay, so basically we can say that maybe for individuals who are earning more that is income, okay, also their what? Their expenses tend to be what? Tend to be high. Okay, so we can infer that is, in case of depending with the trend of the data, in case of increment of what? In income, it will like somehow trigger an increase in what? In expenses. Or basically we can say, for individuals who are earning more income, okay, their expenses also tend to be what? Tend to be more. Okay, even though the model is not it's not strong enough, okay, to predict maybe the exact expenses, okay, based on income alone, okay, but we can say it is moderately fair, positive linear relationship, okay, but the model is not strong enough to give us exact, okay, exact expenses, okay, with change to what? With change in the income amount, okay. So meaning this model, which it would be it wouldn't be advisable to use the model for future prediction, okay. Remember what we said. We usually that is consider, okay, we usually consider that is a model, it's more effective or it's more significant when the correlation, okay, between the two variables are what? They it's more than 0.85 or it's greater than 85%, okay. So that's when we can fully consider that value to predict what? To predict our variables, okay. We'll see how we use correlation, okay, to determine maybe that is the if the model is good, or if like if we can use that that is uh, the independent variable, okay, all the given independent variable to predict what? To predict the outcome. But don't worry about when I talk about model. We'll discuss that during what? During our next lesson. But for this, just know that this value tries to show us that there exists a moderate positive that is a relationship between what? Between income and what? And expenses. All right. Okay. Any question up to that point? Are we good up to that point? Maureen, I can still see your hand is raised. Okay. Are we good up to that point? Can only see 3 people. Okay, I've seen 6, 7. Eh, Okay, I hope we are all good up to that point. Okay, good. Now, I want now to show you that is using that is the analysis tool pack. How can we perform all those that is all those um, measures? Okay, using what? Without using the inbuilt function, okay, or without using the mathematical method, and also without using the inbuilt function. We have some function which are built that they can what? In such way they can compute everything what everything we've what? We've discussed, okay. So I will show you that very quickly, okay. I'll show you that very quickly so that we may now move to what? Or we may introduce the new topic. Okay, so that we may introduce the new topic. So with that, I will start with descriptive statistics, and I'm going to compute descriptive statistics for the two variables. Okay, that is, under descriptive statistics, we are going to look at measures of central tendency, measures of variability, and measures of asymmetry. Even though we did not discuss about measures of asymmetry, remember I said we'll discuss that in our that is in our distribution what? Lesson. Okay, so in that being said, I'm going I can remember we that is in our very first classes we added this analysis tool pack. Okay, if you don't have it, we can still add it. Okay, so go to data. Okay, go to data, please. Then if you go to data, on the farthest that is side of your right hand, okay, you will see data analysis tool pack, okay, or data analysis tools. Okay, if you can't see the data analysis tools, then we can add them. Okay, so if you can't see it, please follow the that is the procedure which I'm going to show you. Okay, so that we may do what, so that we may be together in this. Okay, so if you don't have this data analysis, okay, tool, go to file. Okay, go to file, this file here, we have home, insert, and then we have file. After going to file, go to options. Okay, go down to options. Okay, options. When you go to options, you will see another pop-up window. Okay, or we'll see a pop-up window which is looking like this, or which looks like this. Okay, on this part, go to add ins, ADD hyphen ins, add ins. Okay, once you go to add-ins, okay, down here you will see what, you will see go. Okay, you go to add-ins, then down here you will see go. Click go, and you'll see this kind of add-ins, that is analysis tool pack, that is analysis tool pack with Visual Basic applications. Okay, and then we have euro currency tools, and we have that is solver adding. Okay, mostly used for optimization. Okay, so we'll, for now we are interested with what, an analysis tool pack. Okay, click analysis tool pack, and then what, click OK. Once you click OK, come back to data, and you'll be able to see what, your data analysis tool. I hope we are together up to that point. By show of thumbs up if we are together up to that point. Show me. All right. Okay, good. Let's now continue. So we'll start with what one if you click the data analysis tool pack. Okay, if you click the data analysis tool pack, you can see we have analysis tools here. We have covariance, we have ANOVA for single factor, we have ANOVA for two factors with replication, we have correlation, we have covariance, we have descriptive statistics, we have exponential, we also have histograms, moving average, that is for time series, sampling, regression. You can see all those analyses. But for now, our objective is on descriptive statistics, covariance, and what, correlation. Okay, so let's start with descriptive statistics. Okay, so you'll come to the data, click the data analysis tool pack, then move to descriptive statistics. Okay, then click OK. Once you click OK, it will bring up a pop-up, okay, a pop-up window where now you are requested to input your data range. Okay, you can either choose to that is highlight the data values only, or you may decide to that is to choose even with the titles. Okay, But for that, remember to do what? To check labels in first row. Okay, so in this case, we are going to highlight our range. So you can highlight the range of your data set. Okay, then after that, yes, I've also selected the labels. So labels are in the first row. Okay, and then I want our output range. If you want it in a new worksheet or in a new workbook, you will select all this. Okay, but for my case, I want it in the same worksheet. Okay, so I'm going to choose what? Output range. Okay, so choose output range. Then here you will have now a space. Okay, where an active that is space, where now you can do what? You can just highlight the cell where you want your output to be. Okay, then after that, we now need what? We now need summary statistics. You can now select summary statistics. Okay, and then click OK. Once you click OK, you will get what? You will get now, you will get the summary. Okay, or you'll get the descriptive statistics for what? For your data set. And you can see it is in column, whereby it's showing us the descriptive statistics for income and descriptive statistics for expenses. Okay, so basically our average income, it is what? 41,558. We have standard error. Okay, so our standard error here, it is what? 3690.80. We shall learn about standard error in our next topic when we'll be dealing with regression analysis. Okay,
Just a
then
question.
yes,
Yeah, before you move on, just repeat.
yes,
There's that figure that you did put
uh-huh,
on. There's that figure that on the output range.
uh-huh.
There's a figure that you put there. What's that figure? Where is it coming from?
Which figure? Okay,
On the output range.
let me just repeat. So I come to descriptive statistics, then okay.
Hi, is it possible to expand on your side because I'm not able to see anything?
Now the problem is with the pop-up window. You cannot expand it. You cannot like make it appear to be big. That's the only challenge. Okay, but that is in the recording. It will be more visible. Okay, but basically, let me just take it slow. Go to data analysis, then descriptive statistics, then you will click OK. Okay, once you click OK, you will see we have input range. Okay, so under input range, it is basically requesting you to insert the range of your data. So you will come to your data, you can see, you will come to your data and then highlight all the datas. Okay, the data set you have. Okay, so for my case, you can see I have monthly income and monthly expenses. Okay, so I have highlighted the range of all that data. So that will be our range input. That's okay, Daniel?
So far, it's okay up to there. Yes, just
Okay,
proceed.
then you can either group by columns or rows. If you group with columns, it means your output will be on column format. Okay, if you want that is your output to be in rows, then it will be along the rows. Okay, then since in my range I also included the title, that is the monthly household income and monthly household expense, I will have to choose what? Labels in the first row. Meaning in the calculation it won't consider the first what? The first row. Why? Because the first row is the title. Okay? Good. Up to that point, we are okay, right? All right. Then under output, you have three options there. Output range, meaning for the output range, meaning you will have your outputs or you will have your results in the same what? In the same worksheet. Okay. For that is for the second option, new worksheet, then it means it will open a new worksheet and do what? And output your results there. If you choose new workbook, it will open a new Excel workbook, okay, and paste your output there, okay. But for my case, I said I want my output to be what? To be in the same worksheet. So I chose output range. Then on the right where we are having output range, okay, you can see now we have a clean that is a clear blank, okay. You can just click inside that clear that is area, okay, and then maybe choose the cell where you want your output to be, okay. Once you do that, it will indicate the cell where we will have our output, okay. Then, since we need a summary of our descriptive statistics, make sure you check descriptive, that is summary statistics. Make sure you check summary statistics. And then you come and click OK. Once you click OK, you will have this output. Are we together up to that point now?
Yes, it's clear now. Thank you very much.
Okay, good. So then now after that, I was discussing that is the components which you'll see. You'll see the mean, you'll see the standard error. For the standard error, we'll discuss it in depth. That is in our next topic. That's why I didn't want to introduce it. Then we have the median, okay. Of course, we discuss about the median. We have the mode, okay. It will that is a return one mode, and then we have standard deviation. This is the value we got. We have sample variance. This is the sample variance we got. We have the kurtosis, a positive kurtosis. Kurtosis, I will discuss it during our distribution, but you'll come and see that kurtosis is basically shows us that is a comparison of what? Of the thickness and thickness and thinness of what? Of the tails or of a distribution tails in comparison to that of normal distribution. Okay. Then we have skewness. Okay. Under skewness, we will see how our data is distributed. Okay. Is it distributed to the that is to the right or to the left, okay, or the data assumes a perfect normal distribution, okay. Then we have the range. Of course, we said the range, it is the difference between the highest value and the what? And the smallest value, okay. That is the difference between maximum and minimum. And then we have values for maximum and values for minimum. Definitely, we also have sum, and then this is the count or of the observation. Okay. Yes, that's how we can do what? A summary statistics. Okay, that's how we can do a summary statistics. What about maybe correlation? How can we generate that is a correlation matrix? Remember in our last I can remember one of the classes we said covariance, we usually describe it as a correlation, we usually describe it as what? Correlation matrix. Okay, there is no graphical representation for covariance and correlation because it is only one value output. Okay. All right. The way you cannot visualize mean or you cannot visualize standard deviation. Okay. All right. So let's now go for that is to the second, that is covariance. Let's try and see. Also, covariance also tries to show what? Also tries to output. Okay, all it tries to give us that is the output in matrix format. Okay, it also tries to give us output in matrix format, but let's check that. So you'll go to data analysis, then covariance, select covariance, then click OK. Under covariance now, you will be required to input the range. Okay, you will be required to input the range. So in this case, we are also going to select our range. Okay, the way we did also in descriptive statistics. Then of course labels are in our what? First row. Okay, I want the output maybe to be what? Let me say in a new worksheet this time. Okay, if I select new worksheet, it will output the, or it will give me the output. Okay, in what? In a new, okay, in a new what? In a new that is in a new Excel that is format. Okay, or in a new Excel what do we call it? In a new worksheet. Okay, yes, let's try and see the covariance we got. So this is the covariance we got. Okay, so this is the covariance we got. So all right, let me escape. So when we come to our data, or when we come to our output, I can remember I talked about something. Okay, remember I said this is what? This is our covariance between the income and the what? And the house expense. Not between income and income, or between expense and expense. This is between expense and expense. Okay, and this one it's between income and income. And if you check in the cell, we have what? We have a formula. Okay, inside, whereby it is trying to check the variance of population of what? Of the correlation of the data. So in this case, we only focuses that is on this value, the one without the formula, or the one which that is which meets. Okay, the one which meets that is, it's like the sender. Okay, of income and what? And expenses. Okay, all right, good. I hope we are good up to that point. Any questions? All right, no question. So let's go to the last part now. We want to do what? We want to find now the correlation. Okay, so for correlation, it will give us a correlation matrix. Okay, more so where we have like let's say we are trying to find the correlation between income and income, you will definitely get a 1. Okay, showing it is a perfect that is correlation, because we are checking that is the value between that is the value and itself. Okay, let me admit this. Okay, all right, so definitely let's try and see the output for correlation. Okay, let's see what will be the output for the correlation. So I'm going to now to also to data, then data analysis. I will select a correlation. Okay, I'll select the correlation. Okay, and then after selecting the correlation, I will now input my range. Okay, I will highlight all my range. Okay, then after that, I will also select what? Labels in the what? In the first row, of course, because I've highlighted everything. Now, can we try in a new workbook? Yes, we can try it in a new workbook, meaning it will open another Excel that is a workbook. Okay, so if I click OK, you can see it has opened a new workbook known as book 1. Okay, it has opened a new workbook. So for my case, I usually prefer to put my analysis in what, in the same workbook, meaning I usually output in the same area where we have what, where we have our that is our draw data. Okay, all right, so this is our output. Okay, this is our output. This is how our output looks like. So definitely correlation between income and income, it's 1, because it's one of the same thing. It's why? Because income will explain about income. Okay, expense and expense will explain about expense. Okay, but we have now the correlation between monthly income and monthly expense. Okay, you can see this is the same value we got during our what, during our manual calculation. You can see it is one and the same value. Okay, but this is how we represent. Let's assume you were to create a report about this, so you will basically come and what, copy this correlation matrix. Okay, maybe to the work, or that is the Word document, if we are using Word document, or if you are using let's say PowerPoint to explain your output. Okay, you'll just come and do that, and then of course you'll do some that is some inferences here, or some conclusions. Okay, depending which method you are using. If you are writing a report, you'll paste it in what, in Word. If you are working with what, if you are working with presentation, you will paste it in PowerPoint, and then explain about that is the value. Yes, and that is the end of our first topic, that is practicals. Any question up to that point? Yes, Elizabeth.
How come I'm finding my values are different from what you have, especially from the statistics, the descriptive statistics summary, as well as the covariance.
Covariance. Okay.
Yeah, I got different. Is it?
Maybe
Or
I know why. I know why. Can you see here? Remember here I changed from 100 to 98,000 as it was initially. So check if you have 400s or you have only 3.
Okay, so if I do that, do I have to start again the formula, because I've done that and I've not seen any change?
Really?
Yes. For example, my
Should
mean is 41,500 for the income,
uh-huh.
41,598.
Okay, let me show you, because mine is changing. Unless maybe there is somewhere you did not break the, that is the formula, or you separated the formula, because you can see. Okay, I want you to see, if I change. Okay, this was, let me copy paste this here. This was this value. Okay, this in value, and this one was this one. Okay, so I want to check if the new value after I change that, okay, will be the same. So let's assume for my case I had already done the what? I had already removed the 98,000. Okay, if I go back to 100,000, you can see it is changing everywhere. You can see it has changed here, because it's now 415.98 instead of 58, and here you can see it is 205 instead of what, 204. but for the standard deviation might not change, because it's very it's a difference of 2000. Can you try and see if that will work for you?
Okay, let me try.
Okay. Any other questions?